Good morning, mathematicians. It's Mrs. Post. Today is April 7th. It's a Tuesday. And today, I plan on going over your nth root classwork from yesterday. I just know it was a lot of problems, but a lot of them were also just quick calculations on your calculator. And you did need to pay close attention to the rules that were on the page and also that I talked about in the lessons. So I'm just going to go over that with you guys in just a quick minute. I'm going to give you some of the answers just for the concept of time. But I do quickly want to go ahead and show you what the link looks like that I gave you in the post page, because this is how you log in if you want to access the online textbook, the actual big textbook that we use in the classroom. Now, you guys are always welcome to look at the lesson, and then I try to post it for you as much as I can. So like this nth root lesson is actually 6-4. It's actually numbered as 6-4. 6-4 doesn't really matter, but it's just for finding it in your book. So if you want to look over that, you always are welcome to do that if I don't give you a page out of your green workbook. But if you want to use the larger textbook and you have a pretty good size memory on your computer, I'm not sure if you can do it with a mobile device, but try it and see. I know sometimes I can't get in, the file is just too large. But anyway, I gave you guys a username and password. So it's DKL once you get to the MH Education page right here. Your username is going to be DKL, and then your password is going to be Panther49. And I put that in the post, and you guys are just going to log in. And it gives you some other books too, but you really just need this one unless you're using it for another class. So I'll show you once this gets in there. So definitely can take a while to load, but it's definitely something to try if you want to. Screen. Okay, yeah, Miss Lewis set this up for us. So you can see there's a few textbooks, but you only need the Algebra 2. So you guys can just go ahead and click launch, and then you guys can go to it, and it matches the page numbers, just like in the book that you have. So you can go to whatever lesson that you need to go to for whatever chapter. So if we're in chapter 6, 6-4, if we continue to work on chapter 6, it's also in here, okay? So that's just one thing you guys could do. So let's just go back to the assignment here that you guys were assigned yesterday. Make sure that you have this chart and make sure that you use it. I did go over it in last week's lesson, but it's just nice to have it written out like that. So it just talks about that index. And if it's a square root, that's even. You know that if you have a positive number, you're going to have one positive root and one negative root. If you also have a square root and it's going to be a negative number, you would have no real roots. And that's something you can do if you get an imaginary number. You could put no real roots. That's fine with me. Just kind of be on the lookout for those. And then, of course, it tells you if you have like a cube root or some kind of odd root and you have a number greater than 0, you have a positive number, you have one positive solution. And if you have a negative number inside your radical, then you're going to have a negative solution. That's really as simple as it gets. So just be on the lookout for those. Make sure you're following those. I'm going to zoom in here because I wrote it with the turquoise pen. So that's my fault. So hopefully you guys were able to get some of the more simple problems, like number 1. The square root of 81 is 9, because 9 squared, and we're using a square root here, is 9. You're looking for 2 of the same number. Notice that on number 4, for example, on number 4, you can see how they have a plus or minus here. That's why you put your answer as a plus or minus. So just something to be on the lookout for. You'll see some of that on your assessment today. So you only really need to put it if it tells you. We also talked about in my lesson from last week about how to write them out, if it has a principal root or not. And so hopefully you can see this as a square root. So hopefully you wrote it as 2 squared. 4 is 2 squared, so you get that square root. And then a to the 10th can also be reduced. So 10 divided by 2 is 5. So a to the 5th to the power 2. And you guys can see that's still a to the 10th. It's just rewritten. And so then you can reduce your powers of 2s, get rid of them, get rid of your square root symbol, and you're left with 2a to the 5th. And then I just keep that positive negative there. Okay, and the same thing with number 7. You can rewrite number 7. The power of 12 divided by 3 is 4. So you can rewrite it as b to the 4th to the power 3, which is still 12. But notice that it was a negative. So remember, if you have an odd index and you have a negative number inside your radical, it would stay negative. right? So that's why it's negative b to the fourth. I'll just go over a couple other questions that some of you guys had. So like for example, number 10, I saw this question asked yesterday. And so 4k to the fourth power, you guys can see this is a power of 2. This index is a power of 2. So with that being a power of 2, you have to rewrite these as a power of 2, but it's 4k stuck together. So you can write the whole thing as 4k squared to the power of 2. So you're not changing the value of it. You could go ahead and distribute this 4 to this 4 and this 4 to this k, and then stretch it back out again. Same thing. You could write it like this, where it's 4k to the power of 2, or you could go ahead and, like I said, simplify it back out, where it's 4 squared, which is 16, and then k squared. Either one with me is okay. Either one's okay. All right, so be on the lookout for those. And for numbers like number 16, you can just use your calculator, and you'll see it's supposed to be a negative because it's a negative on the inside and an odd root. An odd index. So it would stay negative 0.3. That's just a calculation on your calculator. And then you can see for number 22, there's two 3x minus 1s. So your answer would be 3x minus 1. And you take the square root of it. And we've done problems like that before. I'm trying to think what was another one you guys had. Like if you miss number 24, that's completely fine. You can factor number 24. You can slide and divide this. Now, I'm not expecting you guys to get every single answer every single time on your assignment, just to kind of be able to go through most of them, right? Attempt them, give it a shot. But yeah, you can factor that out, put it back into parentheses. So when you do that, you slide 36 over, and you factor. 6 times 6 is 36, and negative 6 plus negative 6 is negative 12. Divide by what you slid, and you guys can rewrite it as 6x minus 1. And there's two of them, so it's 6x minus 1 squared. When you take the square root of 6x minus 1 squared, you just end up with 1 6x minus 1, just one of those. So that's just a little factoring. Hopefully you guys remember. You've been doing that for almost 6 months now. And like I say, with number 18, it's just a decimal. You can just square root 0.64, and then the p to the 10th, once again, you can just change it as p to the 5th squared. So the squared goes away. Trying to think of other questions you guys had. There's a couple over here. Number 17, I saw, once you have a negative on the outside, and this is a square root, it's an even root, and you have a negative on the inside, you know you can't have a negative with a square root, or you get an imaginary solution. So you could have written it out like that. I don't know really why I did that, but you could write not a real root, would have been fine. You could just write it as 0.6, negative 0.6i would be fine. Anything like that, just know that that would definitely be an imaginary solution for that one. Here were a couple other solutions. I think those were most of the questions you guys had. Number 12 was a good one. I saw that one come up because you can see that you have a cube root of negative 27. So you have an odd index and a negative number on the inside, which means your solution is going to be negative. So it would be negative 3, because 3 cubed is 27, and you guys can calculate that on Desmos or on your calculator. And when you rewrite the p to the 6th as p squared to the power of 3, like right over here, and you reduce those cubes, you'd have negative 3 and p squared. But you have also this negative. You also have this negative over here that you have to bring down. And you guys know a negative times a negative ends up being a positive. So technically your final answer would be positive 3p squared. So just kind of be on the lookout for problems like that too, where you have that double negative. So you're just trying to break it down as much as possible. I'm trying to see what other problems you guys might have had. I think that was mostly everything. And I know you guys can find these answers online. They're really easy to find. But I just wanted to explain a couple of them, like number 6, the negatives on the outside, so you just carry it down all the way. If there was a negative on the inside, you would have a double negative again for problems like number 6. I do have the absolute value bars on here. That's the way you're supposed to set it up, because the number over here is, we don't have a positive or negative sign, but it's fine. We're not really going to go over that right this minute. You don't have to worry about the absolute value bars. I think that's mostly everything. from that page. Let me see what else. Let me zoom out and go back in, and then I'll show you what I want you guys to do today. Yeah, these were mostly just calculations on the second page. Like they were really quick. You just could just use Desmos or just your calculator. And you guys can use negatives. Whenever you take a cube root, you wouldn't get an imaginary number, remember, because it's an odd index, it's an odd root, and you can have a negative solution in there. And just notice that these don't say positive or negative, so you don't have to write them as such. And these are all just calculations on your calculator. You see how number 4 had a negative on the outside, so you have to bring that negative on the outside down. It's not inside the radical. What other questions that you guys have had? Same with number 15, that negative's on the outside, you just bring it down. And if you guys had tried the word problems and you substituted in that value of 300 feet for L, it would just be 5 times 300, and then you would have a 2 on the outside. It's just like we're going to talk about these actually tomorrow, multiplication of square roots or radicals. And so you just simplify what's inside the radical and multiply it by 2. And that's it. And you would get something like 77.5 miles per hour. And then the very last problem, same thing, your h they're giving you as 150. So 150 is your h. So you just plug that in, use substitution, use order of operations, and then take the square root, and you would get something like 1,105, 1,100 or something like that. Okay, 1,105, and that would be your final answer for this last question here if you attempted it. If you didn't attempt it, it's fine, but I'm just putting these problems out there so you guys can get as much practice as possible. Okay, so real quick, I want to go back and I want to show you your assignment for today. You have a quick assessment, it's a 10-pointer, and it is multiple choice mostly. You're just going to simplify some of these radicals. I just made these up, and it's not an USA test prep, as you guys can see. The very last one, it's not multiple choice, just calculate it on your calculator. You guys can just mark on it, or you can try to edit it as a PDF. I'll send it over both ways to you, as a Word and as a PDF document. So I'll send that over to you. Actually, you guys have it, a copy of it. I already posted it. And then all you have to do is just simplify these out and send it back to me. And just make sure that very much is very important. Make sure you're doing this on your own and you're not doing it with help from your friends. It's an independent assignment because it is an assessment. It is a mastery grade. You should be doing it on your own. It is multiple choice. That should help you eliminate some of the possibilities, some of the choices. And so just make sure that you're doing it on your own. You're not helping each other, sending the answers out. I can't really help you on this one. It's just a quick one. Just make sure you're doing it on your own. I want to make sure that all your work is your own. That is an academic integrity issue if you're not doing your own work. If you're getting help from another on problems like this, there are some assignments you can get help from your friends on. This is not one of them. But getting help from your friends does not mean copying your friend's work, right? It means asking them a simple question. Okay. So that is it for today. So you guys are going to work on your assessment, review your answers from yesterday. If you have any other questions from yesterday's assignment, you can come back and see me. I'll be available from 10 to 12 today, like always, and 2 to 4. So if you have questions, post them in the post office, send me a private message, whatever you want to do. Get your answers, get your questions answered, so I can help you before you take the assessment. Do not email me tomorrow and say, I don't understand how to solve nth root radicals. I will not help you at that point because this is our second week working on them. If you need help, you have to be managing your time and questioning me every day. You'll get a math assignment every day. That's how math works. You will not get projects from me right this minute. Right now, we're just trying to make sure you're getting a little bit of a lesson every single day. Please stay on top of your math and ask me daily if you have a question about it. Okay, you cannot go a week behind. Okay, so that is it. Work on your math, and I will see you guys later. Have a fabulous day. Bye, mathematicians.